All right. Let's get started here. So let's start with some questions. Questions from homeworks or in general. Maura? Yeah, go.
I forget what they're called. You know where it's like under the square root and you'll like.
If you have a square root in there, it's a radical. The number under the square root is called the radicand.
So
if that matters, but
multiplying those, so if it's like the same denominator, we just make it that number, right? Or I mean, multiply across.
I think so, but can you give me like a specific numbers example? Because I just want to make sure that the answer I'm giving you is a good answer. So if you can give me just like make something up that you're talking about.
So like if it's like the radical like square root or like 2, yeah, and then like over 2.
Okay.
And then times like the square root of like 4 over 2.
Let's make it 3.
Okay.
Because the square root of 4 over 2 is just 1.
Okay.
Because the square root of 4 is 2 and 2 over 2 is 1.
Okay.
So yeah, when we multiply this, those multiply straight across, and because they're both under square roots, you can multiply the radicands, the number underneath them, together. And this multiplies straight across.
Okay, perfect.
That is correct.
Okay, thank you.
Who's next on questions on things? Joey. Chapter 6, any question? Sure.
Can you do like number 6?
6, tangent of 195? Yeah, no problem. So the directions for this say to use your sum and difference identities to find the exact value, right? So the first thing I want to do is I want to rewrite tangent of 195 as either the sum or difference of 2 unit circle angles. Now, I think that I would do sum here. Really anything that's like bigger than a normal unit circle angle, I'm probably going to do as a sum. But you could do it as a difference also if you wanted to. So I just need 2 angles from the unit circle that add up to 195 degrees. 135 and 60 would be fine. So I'm going to go and look at my angle sum and difference identity for tangent. And because it's an angle sum, I'm going to be using SD6. So that gives me tangent of 135 minus tangent of 60 over 1 plus tangent of 135 times tangent of 60. Does that feel okay so far, Joey? Okay. So now I'm going to go to my unit circle, and this time I'm going to pull the values for tangent 135, tangent of 60. So looking at my unit circle, tangent of 135, remember tangent is y over x. And tangent of 60, again, is y over x. There. Feel okay? All right, so now I know that this square root 2 over 2 divided by negative square root 2 over 2 is just going to be negative 1. Right, because the numerator and denominator are the same fraction. Just 1 is negative. Over here, the over 2's cancel, right? So that leaves me square root 3 over 1, or just, well, square root 3. So far, so good. Okay. This is also 1, right? Or -1, I should say. And then this guy, the same thing happens. So I have that. Because I have -1 times square root 3. So I just have negative square root 3. So far, so good. Now, I don't have any fractions in fractions here, which is great. I love that. Yay. But I do have radicals in my denominator. So let's take care of that. So to do that, I'm going to multiply the top and bottom by the conjugate of the denominator. Remember, the conjugate is the same as the denominator, just with the opposite sign in the middle. Cool so far? Luca.
If we were taking the conjugate and there's like multiple signs,
So if this was -1 minus square root 3, the conjugate would be -1 plus square root 3. The only sign that changes is the one in between the two terms. And I really should say the one that's attached to the radical is really what we mean there. Does that feel okay? Good question, though. Like, that's an important thing to ask. So now we're going to FOIL out the numerator. So I get -1 times 1, -1 times root 3, negative root 3 times 1, and then negative root 3 times positive root 3. And then the denominator is just that difference of two squares thing. So that can just multiply out to that. You could FOIL it too if you wanted to, but it's not necessary if you use that shortcut. Squares cancel square roots. So the denominator we have is 1 minus 3. And then I have a -3 and a -1, so that's a -4. Then I have negative root 3 and another negative root 3. That gives me -2 root 3s. And now I notice that this can reduce because every coefficient is even. So I'm just going to kind of write this as two fractions with a common denominator. So -4 divided by -2 is 2. And then 2 root 3 divided by -2 is going to be -2 root 3, but it was already negative, so negative and negative makes a positive. So that should be my answer, right? And again, all of these guys are checkable. So we had tan of 195. Ooh. And then I had 2 plus root 3 is not the same number. Uh-oh, SpaghettiOs. Should be 2 minus root 3. Where did I drop a negative at? Somewhere along the lines. Yeah. Ooh, Billy, what did I do here? Let's take a look. It's probably back here. Seems okay. That seems okay. I tapped to do the wrong formula. That happens every once in a while. Did I write that down wrong? Sure did. That's the problem. Ha! Mr. Kulik, you bozo. That was supposed to be there. I'm so sorry, guys. But isn't that like a, like a nice, what do I do if this happens, right? Like, we get to see it in real time. All right, so let's see. We have -1. That'd be a positive root 3. That's a positive root 3. So that would be plus there. So that's plus. So that's minus. And there's our correct answer. Woo! It's bad when it's the first possible thing you could have done that was Or use the minus formula instead of the plus formula. Let that be a lesson to everyone. Maybe double check that before you dive in so you don't have like a million mistakes to fix. Joey, does that help? Okay. And just for the record here, again, Joey picked 135 plus 60. That was not the only possible option. You could have done like 140, or you could have done 150 plus 45. You could have done, you could have done like, let's see. You could have done like, you could have done like 225 minus 30, right? You could have done lots of stuff there, right? There's not just one way of doing that. You should get the same answer, though, regardless of how you constructed 195, as long as you used unit circle angles. Marianne, did I see your hand coming up? Oh, okay.
You can subtract.
Yes, yeah, you could have done like 225 minus 30 or something. Could have done that, absolutely. Absolutely. Okay. Do you guys have chapter 7 questions you guys want to talk about? Ellie?
Can you do a log cosine problem?
Yeah. Do you have one in particular that you want to look at?
No,
Or
just any.
okay. Well, I'm just going to pick one of the problems from the problem set then. Let's do number 16. Sound good to you? Okay. So, what situation is this? Okay, is it, when I say situation, do I mean angle, angle, side, angle, side, angle, side, side, angle, side, angle, side, or side, side, side? Great. Luca says side, side, side. How did you know that right away, Luca? Because those are all side lengths that are given. You can tell that because none of them have the angle symbol out front, right? They're all lowercase letters. So I don't even need to draw a picture to tell it side, side, side. Now, before I start a side, side, side problem, there's something I need to check first to make sure the problem's even possible. Does anybody remember what is the first thing we need to check on a side, side, side problem? Great. So the sum of the two legs has to be greater than hypotenuse. Which one of these is the hypotenuse? 12. How'd you know that, Ellie? It's the biggest one. So 5 plus 10 is certainly bigger than 12, so this problem is possible. Now, we know that for side, 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 we're going to do a law of cosines problem. You would have known that also because you asked for a law of cosines problem. So let's draw ourselves a picture here to start. Okay. So we're going to have to start by solving for an angle. Which angle do I need to solve for first when there's 3 angles remaining to solve for? The biggest angle. So Ellie, which one is going to be the biggest angle, X, Y, or Z? Correct. How do I know it's Y? Not because of looking at the picture. I drew my picture not to scale. It's because it's opposite the biggest side. So the side length is going to tell you the biggest angle also. Cool? So for my law of cosines, I'm going to have the side or the angle that I'm solving for. That's the side that's by itself in the formula. And then I'm going to have leg squared plus leg squared minus 2 times leg times cosine of the angle that we're searching. So far, so good. So now I need to get angle y by itself. So I'm going to subtract these two over. And then I'm going to divide this stuff over. How do I know that I'm supposed to subtract those first things and then divide this thing? What operation is going on between the 5 and the 10 that I've circled in blue up above? Addition. So to undo that, I have to. Okay, so the 5 and 10 are being subtracted. What operation is going on between the 2, the 5, the 10, and the variable? Multiplication. So to move those over, I have to divide. And now last question is, how do I get rid of this cosine in front of my angle y? Cosine inverse. Now notice when I'm doing this, I'm not like doing any little multiplications or additions or anything along the way. I'm just leaving all the numbers as they are. And I'm going to type it all into my calculator in one big swoop. Joey?
Set up the whole thing different.
I don't know. We can take a look.
It had like you would add top.
We'll take a look here in a second. We can do that. All right. So cosine inverse, and then alpha y equals. So I'm just typing this in exactly like it looks. Oops. Right, so that is all in. So I get 100.95. Now, with two angles remaining, which angle do I need to solve for next? I need the smallest angle when there's two angles remain. And I guess I should say smaller. Okay, so we'll set it up the same way. Yes. Yes. Or what I would prefer to do is do a law of sines here. So because I know angle y, I can do sine of angle y over side y equals sine of angle x over side x. Now I'm going to cross multiply, divide by 12, and do the sine inverse of both sides to get the angle x by itself. Ellie, is it okay if I do that all in one step? Okay. It's been a minute since we've been in class. I just wanted to ask before I go and like shortcut through a bunch of algebra that if you're not sure on what to do, I don't want to leave anybody behind. particularly the person that asked the question. Shh. So I'm just going to use the ants. Stop talking, please, girls. Thank you. We use the ants command to just substitute in that angle that we just solved for, rather than typing in all the decimals. So there I get about 24.15. And then how do I find the last one? Excellent, yes. Oops. So 54.90. Feel okay?
Yeah.
Last thing I would do before I finish is just to do a quick little check. Make sure the biggest angle is opposite the biggest side. The medium angle is opposite the medium side. And the smallest angle is opposite the smallest side. And that all looks good. Okay, doke. Joe, you wanted to look at one of these delta math problems because it wasn't working for us? Yeah, if you had a problem, I'm sure other people had a problem. Let's take a look here. All right. Sample student page. Okay. And it was the law of cosines problems?
Yeah.
Which one? Did it matter?
I don't think it mattered. No.
Okay. All right, so I'm going to do this. That just, okay, didn't do what I thought it would do. All right, so I'm going to start by drawing myself a picture. Since I know it's a side angle side situation. Okay. So, yes, that's fine. So for the side angle side, I'm going to solve for m squared. So that's going to be leg squared plus leg squared minus 2 times leg times leg times cosine of the angle. So m should just be the square root of that stuff. It was the other ones. Okay, let's take a look at that then. Because this feels pretty cut and dry, right? It's okay. Let's take a look at this one then. So LMN, we're told side L is 13, side M is 74, and side N is 83. And we're looking for angle M to the nearest tenth of a degree. So remember what we had said. Which angle do we want to solve for first? I want the biggest angle first. So I'm going to do that still, even though it's not asking me for angle N. I'm still going to find angle N first, because if I don't, it's very possible that if I try to do angle M first, I'm in a side angle situation, and I might end up finding the wrong angle from the wrong, because I'm looking at the wrong triangle, which I want to avoid. So this one is going to be like a two-stepper. So I'm going to do that all in one step. Is that okay, Joey? I figured that, like, the algebra is not the issue. Okay, so let's see what that comes out to be. Now, if they gave me an acute angle for, or if they asked me to solve for the biggest side, or biggest angle, excuse me, that's not a big deal. But if I'm asked for like the middle angle or the smallest angle, I need to be real careful there and still go in the proper order. So that comes out to be 130.28. And now to find angle M, I'm going to do a law of sines. Yeah, I think that's probably the issue, that if you're going out of order, you're not finding the biggest angle first and then using the biggest angle to find the next one. I think you probably are stumbling inadvertently into a side angle situation where you're just finding the wrong, or information from the wrong triangle, which is really common. So even though it seems like you're doing extra work, you kind of need to do it in that order. So 4285, it says 1/10 of a degree, so that should be 42.9. Let's see if it takes it. Yeah. So that's probably what was happening. So anyways, that should work if you kind of go in that order. Again, if you're not careful, you could catch a SSA situation, particularly if this problem had asked for, instead of asking for angle M, which you might have gotten away with doing it, just finding that directly. If it asked for angle L, though, you would have been almost assuredly in a side angle situation where if you went out of order, it's going to be an issue. Okay. Other questions from me before we get to it here? No? Okay. So our last section is 7.4. In 7.4, we're going to learn how to find areas of triangles. So let's say that we have something like this. Now you might remember from geometry, what's the area formula for a triangle? Oh, come on, guys. The area formula for a triangle? That's the Pythagorean theorem.
They equal 180.
That's the sum of the interior angles.
Is that base times height?
Close.
It's like one half times base times.
There you go.
What is it?
1/2.
1/2 base times height, right?
Once I learn something like a year after, my brain is like,
So look at this triangle that we're given here. What would base the B be? 10, sure. What is the height? It's not 27. The height is that segment, right? It's the distance from the base to the angle opposite the base. Ugh. Right? But if we look here, doing this makes a right triangle, doesn't it? And I know an angle and a side in that right triangle. Can I use SOHCAHTOA to solve for H? Yes, right? Relative to that 43 degrees, H is opposite, adjacent, or hypotenuse. The H is opposite. Yep. And the 27 is hypotenuse. So we know that sine of 43 is equal to H over 27. Or H is 27 times sine 43. So I could calculate my area now doing this. So, in general, so if we just have some arbitrary triangle ABC, we can say something like the area is 1/2 BC sine A, or you could say it's 1/2 AC sine angle B, or you can say it's 1/2 AB sine angle C. That basically you would need this information, or that information, or that information. What type of situation is that? Is the information circled in blue, yellow, and green? Side angle side situation, right? Now, what would you do if you had like an angle side angle, or an angle side, or a side side angle situation, and you wanted to use this formula? you'd have to use the law of sines until you got a side angle side situation where you could apply the formula, right? You'd have some solving to do in front of that. What do we do if we have a side situation? Well, we have a different formula that we can apply there. I'm not going to derive this formula because it's a lot of algebra. We kind of derived that one because it was sensible to do. This one is kind of rough. So in a side situation, we can calculate the area again of the triangle directly by doing the square root of s times the square root of s minus a times s minus b times s minus c, where s is the average value. I'm sorry, not the average value. We call that the semi-perimeter because it's like 1/2 of the perimeter. Right, the perimeter of the triangle is just the distance around a plus b plus c. So if it's half, the prefix for half is semi, right? All right, let's do a couple of examples here. All right, let's say we have a triangle with side lengths 4, 5, and 8. What situation are we in? Side. Before I try to calculate the area of this, since it's a side situation, what do I need to do first? I need to check to see if this triangle is even possible, right? If the triangle is impossible, there's no area to compute. Everybody's good? How do we check if the triangle is possible? Yes. So the hypotenuse in this case is 8. And 9 is definitely, I put it the wrong way. Goodness gracious, Mr. Kulik. 9 is definitely bigger than 8. So we can do this. So let's start by calculating our S. So that's 4 plus 5 plus 8 divided by 2. That is 17 over 2. So my area then will be the square root of 17 over 2 times 17 over 2 minus 4 times 17 over 2 minus 5 times 17 over 2 minus 8. So you could type that into your calculator, or if you're feeling fancy, I'm feeling fancy right now, you could make some common denominators and do the subtraction. 8 is really, or 4 is really 8 over 2. So that's going to be 9 over 2. 5 is really 10 over 2. So that's going to be 7 over 2. And 8 is really 16 over 2. So that's going to be 1/2. So, at this point, I don't want to do that. It's just not so bad. So that's 9 times 17 is 153. Can you do that in your head? You know the trick to doing it in your head? This is what I think about in my head. Instead of 9, I'm going to think about it as 10 minus 1. Because I can do 170 minus 17 in my head pretty easily. 17 times 9, if I try to carry this, it's hard. It's a lot harder, right? So 153 times 7, how am I going to do that? Same way. It's a little harder. 3 times 153 is 153 plus 153 plus 153. So it should be 459. And that stinks. That subtraction problem stinks. That's hard to do in your head because you have to carry stuff. So 41 and then 30 more is 71. So 1,071. So you could leave that as your answer. Or what else could we do with that? You guys okay?
I've had this cough since before Christmas, and it's not good.
Gross.
No, it's gross.
I heard from somebody that there's something going around called the 100-day cough.
I saw that on TikTok.
So what do we get there? 32.73 or so. What do you guys think? It is pretty easy. What is all you have to do? Plug it into the right formula and then just grind it out on your calculator, right? Now notice at the end I wrote units squared because this is an area as opposed to a length that's going to have a square unit like feet squared or meters squared or inches squared or yards or squared or miles squared or whatever squared. Everybody's okay? Okay, that's the gist of 7.4. It's literally just these two formulas. Make sure you're using the right formula for the situation. No, this is the easiest section in the chapter. No way, Jose. Nothing weird's happening. So you should be able to do 23 through 30. Should take you all of about a minute and a half per problem because you're literally just typing it into formulas. The only confusing thing that can happen is in the side situation, you have to remember to check to make sure the problem's possible because you would not put it past Mr. Kulik to sneak a not possible problem in there. Yeah, it's lovely to catch them because it's like, that's a lot less work. Can they all just not be possible? But you do need to be careful there, okay? What should you expect next time? Homework quiz. Should cover up through like, it should be 7.1 and 7.3. So no SSA case. Well, in chapter 6. You probably see a chapter 6 question, a 7.1 question, a 7.3 question. Deal? Okay. Oh.
Look, here's your tries.